Welcome to Astronomy Daily, your source for the latest developments in space exploration and astronomical discoveries. I'm your host, Anna, and today we'll be exploring Elon Musk's ambitious timeline for reaching the red planet, a groundbreaking discovery about Mars's atmosphere that's been a decade in the making, and unprecedented views of our sun's outer atmosphere that are revolutionizing solar science. Then we'll journey to Jupiter's icy moon, Europa, where recent observations reveal a surprisingly dynamic surface, before examining a mysteriously perfect sphere discovered deep within our Milky Way galaxy. So settle in as we embark on this cosmic journey through the latest and most fascinating developments in our quest to understand the universe around us. Let's start with Elon's latest plan. SpaceX CEO Elon Musk has revealed ambitious plans to send an uncrewed Starship to Mars by the end of 2026. This timeline would coincide with a crucial astronomical window that occurs only once every 2 years, when Earth and Mars align in their orbits around the Sun to create the most efficient path between the two planets. This alignment would minimize both travel time and fuel consumption, with the journey to Mars expected to take between 7 and 9 months. Despite the optimistic timeline, Musk himself acknowledges the challenges, giving the mission only a 50-50 chance of meeting this deadline. If Starship isn't ready by then, SpaceX would need to wait another 2 years for the next optimal launch window. What makes this proposed mission particularly fascinating is the planned cargo. Rather than traditional scientific equipment, Musk intends to send one or more Tesla-built humanoid Optimus robots as a simulated crew. These robots would serve as stand-ins for human astronauts, potentially testing various systems and protocols that would eventually be used by actual people. According to Musk's vision, human crews would follow on the second or third Mars landings. His long-term ambition is staggeringly bold, eventually launching between 1,000 to 2,000 ships to Mars every 2 years to rapidly establish a self-sustaining permanent human settlement on the red planet. This timeline represents a significant shift from NASA's more conservative approach, which aims to return humans to the moon first, using Starship as the landing vehicle, before attempting Mars missions sometime in the 2030s. Musk has long advocated for a more Mars-focused human spaceflight program, previously targeting 2024 for a first crewed mission to the red planet. It's worth noting that Musk has a history of setting ambitious timelines that later get revised. He had previously mentioned sending an unmanned SpaceX vehicle to Mars as early as 2018, a goal that wasn't realized. The recent setback with Starship's 9th test flight, which ended with the vehicle spinning out of control and disintegrating, highlights the significant technical challenges that remain before any Mars mission becomes reality. Nevertheless, Musk appeared undeterred by the failure, describing it as providing good data to review and promising a faster launch cadence for upcoming test flights. As SpaceX continues to refine its massive Starship vehicle, the race to put humans on Mars intensifies, with significant implications for the future of space exploration and potentially human civilization itself. While we're talking about Mars, in a breakthrough discovery, NASA's MAVEN mission has finally observed a long-theorized atmospheric escape process at Mars after a decade of searching. Scientists have directly detected a phenomenon called atmospheric sputtering, which works similar to a cannonball splash in a swimming pool, but on a planetary scale. When energetic charged particles from the sun crash into Mars's atmosphere, they essentially knock atoms out into space, gradually eroding the planet's atmosphere over billions of years. Dr. Shannon Curry, MAVEN's principal investigator at the Laboratory for Atmospheric and Space Physics, explains that previous evidence of sputtering was like finding ashes from a campfire. Scientists knew it happened, but had never directly observed the process until now. This discovery is crucial to understanding Mars's dramatic climate evolution. Billions of years ago, Mars had a thick atmosphere and liquid water flowing on its surface. However, when the planet lost its protective magnetic field early in its history, the atmosphere became directly exposed to the solar wind and solar storms, making it vulnerable to processes like sputtering. To make this observation, MAVEN scientists needed precise, simultaneous measurements from 3 different instruments aboard the spacecraft, capturing data from both the day side and night side of Mars at low altitudes, a process that took years to achieve. The result was a new kind of map showing sputtered argon in relation to the solar wind, revealing argon at high altitudes exactly where energetic particles had collided with the atmosphere. Perhaps most surprising, researchers discovered that this atmospheric erosion is happening at a rate 4 times higher than previously predicted, and the rate increases even further during solar storms. This confirms that sputtering was likely a primary driver of atmospheric loss in Mars's early history, when the sun's activity was much more intense. The findings, published in Science Advances, provide critical insights into the conditions that once allowed liquid water to exist on Mars's surface and the implications for potential ancient habitability. By understanding how Mars lost its atmosphere, scientists gain valuable knowledge about planetary evolution and the fragility of conditions needed to support life as we know it. Next up today, the sun's outer atmosphere, known as the corona, has long been a source of fascination and frustration for scientists. Its extreme temperatures, violent eruptions, and towering prominences have been difficult to study in detail, until now. Thanks to a revolutionary adaptive optic system called CONA, installed at the 1.6-meter Good Solar Telescope at Big Bear Solar Observatory in California, we now have unprecedented views of the sun's most elusive layer. These new observations provide the sharpest images ever captured of the corona, revealing details that have never been seen before. One of the most striking discoveries is an incredibly detailed view of coronal rain, delicate threads of cooling plasma cascading back down to the solar surface. Some of these plasma threads are astonishingly narrow, less than 12 miles across. Unlike rain on Earth, this solar precipitation doesn't fall straight down but follows the sun's magnetic field lines, creating beautiful arching and looping patterns as it returns to the surface. Perhaps even more exciting is the first ever observation of what scientists are calling a plasmoid, a finely structured plasma stream that forms and collapses rapidly. This snake-like feature moves at speeds approaching 62 miles per second across the solar surface. Dr. Vasil Yurkishin, who co-authored the study, notes that these features have never been observed before and scientists aren't entirely sure what they are. The new imaging technology has also captured stunning views of solar prominences, those massive loops of plasma that extend from the sun's surface far into the corona. These detailed observations show these structures dancing and twisting in response to the sun's magnetic field with unprecedented clarity. These sharper views aren't just visually spectacular, they're scientifically invaluable. They may help solve one of solar physics' greatest mysteries: why the corona blazes millions of degrees hotter than the solar surface itself. The technology also provides crucial insights into filament eruptions and coronal mass ejections, powerful blasts that can impact space weather and create spectacular auroras on Earth. Dr. Thomas Rimmel, National Solar Observatory Chief Technologist, explains that this new system finally closes a decades-old gap in our observational capabilities, delivering images of coronal features at 63 kilometers resolution, the theoretical limit of the telescope. Scientists hope to bring this groundbreaking technology to even larger telescopes, including the 4-meter Daniel K. Inouye Solar Telescope in Hawaii, promising an even closer look at our star's most dynamic regions. Next, some myth-breaking. You might think that icy worlds are frozen in time and space. After all, they're covered in ice. But Jupiter's moon Europa is proving to be far more dynamic than previously imagined. Recent observations by the James Webb Space Telescope have revealed fascinating changes happening on this distant, frigid world. Europa's surface is showing evidence of both amorphous and crystalline ice, two different structural forms of frozen water. This distinction is significant because on Europa, the natural state should be amorphous ice. As the moon orbits Jupiter, its surface is bombarded by charged particles trapped in Jupiter's powerful magnetic field. This radiation bombardment disrupts the crystal structure of ice, converting it to an amorphous form. So why are scientists finding crystalline ice on the surface? Dr. Ujjwal Raut of the Southwest Research Institute believes this points to active processes bringing fresh water from below. Our data showed strong indications that what we are seeing must be sourced from the interior, perhaps from a subsurface ocean nearly 20 miles beneath Europa's thick, icy shell, Raut explains. The most compelling evidence comes from an area known as Terra Regio, a chaotic terrain region where scientists have detected not only crystalline ice but also sodium chloride, essentially table salt, along with carbon dioxide and hydrogen peroxide. The presence of these compounds strongly suggests they originated from Europa's subsurface ocean. What's particularly remarkable is how quickly these changes occur. In some regions, the ice is recrystallizing in cycles as short as 2 weeks. This rapid transformation indicates that Europa's surface is likely porous and warm enough in certain areas to allow for quick recrystallization, despite the constant radiation bombardment. Scientists believe two main heat sources are at work beneath Europa's icy shell: tidal heating from Jupiter's gravitational pull and radioactive decay in the moon's core. These processes warm the subsurface ocean and force water upward through cracks and fissures. This water may reach the surface through various mechanisms, including diapirs, essentially stovepipes that convey warmer water and slush upward, or through geyser-like plumes that shower the surface with ice grains. The discovery of these dynamic processes adds to the mounting evidence for a liquid ocean beneath Europa's icy shell, making this moon one of the most promising places in our solar system to search for conditions that could support life. The upcoming Europa Clipper mission will study these regions in much greater detail during its close passes of this fascinating moon, potentially revealing even more about Europa's hidden ocean and its constant cycle of surface renewal. Finally today, a puzzling discovery in our own backyard, so to speak. In the vast universe of spherical objects, planets, moons, and stars, astronomers have recently discovered something that stands out for its extraordinary perfection. Deep within our Milky Way galaxy lies a mysteriously circular object that has left researchers both fascinated and puzzled. This celestial bubble, accidentally discovered by astrophysicist Miroslav Filipovic of Western Sydney University, has been named Teleios after the Greek word for perfect, and for good reason. While scientists believe it's a supernova remnant, the expanding shell of gas and dust left behind after a massive stellar explosion, Teleios exhibits an almost unnaturally perfect form. What makes this discovery so remarkable is its astonishing symmetry. Teleios has been measured with a circularity score of 95.4%, placing it among the most geometrically perfect supernova remnants ever observed. As Filipovic explains, this level of symmetry is extremely unusual. Typical supernova remnant shapes vary dramatically, he notes, either from asymmetries in the initial explosion, disruption from expanding into an imperfect environment, or various other interfering factors. Yet Teleios displays none of these common irregularities. Instead, it appears to have expanded with almost textbook perfection, as if created in an idealized simulation rather than the chaotic reality of space. The secret to Teleios' perfect form may lie in its location. Situated 2.2 degrees below the galactic plane, it exists in a region with significantly less interstellar gas and dust. This relatively empty environment has allowed the remnant to expand undisturbed for thousands of years, maintaining its symmetrical shape. But the mysteries of Teleios don't end with its shape. Unlike most supernova remnants, which emit radiation across multiple wavelengths, Teleios is only detectable in radio frequencies, with just a hint of hydrogen alpha emissions. This peculiar characteristic has made it difficult for astronomers to determine exactly what type of stellar explosion created it. The most likely explanation is that Teleios resulted from a Type 1a supernova, the spectacular death of a white dwarf star that consumed too much material from a companion star. Alternatively, it might be the result of a Type 1ax supernova, a similar but less common event that leaves behind a zombie star. However, the observable data doesn't perfectly match either model. Using data from the Australian Square Kilometre Array Pathfinder and the Murchison Wide Field Array, researchers estimate that Teleios spans somewhere between 46 and 157 light-years across, depending on its exact distance from Earth, which is still being determined. As researchers continue to study this celestial oddity, Teleios stands as a reminder that the universe still has plenty of perfectly formed mysteries waiting to be unraveled by our increasingly sophisticated astronomical instruments. That wraps up today's journey through our cosmic neighborhood. From Elon Musk's ambitious plans to reach Mars, to the groundbreaking discoveries about atmospheric loss on the red planet, to unprecedented views of our sun's fiery corona, to Europa's surprisingly dynamic, icy surface, and finally to the mysteriously perfect sphere called Teleios, we've covered quite a bit of astronomical territory today. These stories remind us that our understanding of the universe continues to evolve with each new observation and technological advancement. Whether it's solving ancient planetary mysteries or capturing never-before-seen solar phenomena, the field of astronomy remains as exciting and full of discovery as ever. I'm Anna, your host for Astronomy Daily. If you enjoyed today's episode, please visit our website at astronomydaily.io, where you can listen to all our back episodes and find more information about the stories we've covered today. Don't forget to follow us on social media as well. Just search for Astro Daily Pod on Facebook, X, YouTube Music, Instagram, Tumblr, and TikTok to stay updated with our latest content and join our community of space enthusiasts. Until next time, keep looking up.